Welcome to Brain Vision.
We're asked to find the horizontal component of the force that's exerted on a block due to an input force of 100 pounds. And to do that, we're going to first find the magnitude of this force BD, and then we're going to find the x component of that force, and that will be the force that is exerted on the block. So to start with, I'm going to first find the length from B to F. So BF, that's going to be equal to AB times the sine of 15 degrees. And the problem gives us AB. So that's going to be 4 times the sine of 15 degrees. And that's going to be equal to 1.03 inches. Okay, next we're going to find this angle theta. So to find theta, you can write out the following equation. So we have theta is equal to the sine inverse of 1.03 divided by 6. And that will give us an angle theta of 9.9 degrees. And next we're going to find the length from point A to point D. So to do that, we do A to F. So we do AF plus FD. So we can write out the following. So AD is equal to 4 times the cosine of 15 plus 6 times the cosine of 9.9 degrees. And that will give us a length of 9.78 inches. And next we can write out the following relationship. So we have that the sum of all moments about a point A is equal to 0. So the moments in the x direction can write as this. So we have 100 times 10 times the cosine of 15 degrees, and then minus the moments in the y direction, which is the force of BD times the sine of 9.9 degrees times 9.78. And what we can do with this is we can set it equal, so we set this equal to 0. So set that equal to 0. And then we can solve for this f of BD term. So solving for that term, so rewriting this term, we get f of BD squared is equal to 100 times 10 times the cosine of 15 degrees divided by 9.78 times the sine of 9.9 degrees. And then we calculate this expression, take the square root of both sides, and that'll give us a force of 572.78 pounds. Okay, next we're gonna take this force here, and we're gonna find the x component of it. So to do that, we can write out the following. So the x component of that force, which I'll call f of x, that's going to be equal to the force we just calculated times the cosine, since it's the x component, the cosine of 9.9 degrees. And this will give us a force of 564.18 pounds. And this is pointing in the right direction.